up to right now is we're adding polynomials. Now, adding is one of the easiest things you can do with polynomials because it's no different than actually simplifying one big single polynomial. So let's get this one written into your notes. 3x squared y plus 2xy minus 4 plus 4x squared y cubed minus 5x squared y plus 7xy minus 5. Okay, let's get that written down so you can actually think about it. Yesterday we talked about like terms. Like terms have to have the same variables with the same exponents. So let's take a look here. We need to identify some like terms. I'm going to start off here. Let's take a look at this one. Is there anything that's a like term with this one right here, 3x squared y?
Yes.
Which one?
Yes.
Negative 5x 2y.
Okay, good. This one right here, negative 5x squared y. Grace, why is this one not a like term?
Because of the y cubed.
Good, because of the y cubed. It has to be the exact same variables with the exact same exponents to be like terms. Watch out for the signs that come before them. This is, the coefficient is 3, and I'm adding it to a coefficient of negative 5. So that's something sometimes people miss. 3 minus 5. So that gives us negative 2 x squared y. Okay? Then we can check out the next one. Okay? This, is there any like terms with 2xy, Luke?
What?
Is there any like terms with 2xy?
Sure.
Which one?
Sure. 7xy.
7xy. You're checking for the same variables, same exponents. So we're putting together positive 2 and positive 7. So positive 2 and positive 7 gives what? Positive 9xy. Now notice when you're combining like terms, don't forget the exponents don't change when you combine like terms. Okay? Anything that is a like term with negative 4?
Yes.
Yes, negative 5. So negative 4 and negative 5 get combined, and that gives us negative 9. Now there is something left over.
Yep.
Okay.
That 4x 2y3.
Right, so we can't just get rid of it. We need to keep it. 4x squared y to the third.
Yes.
And so you need to be able to include that in your polynomial in your final answer.
That's the final answer?
Now, a lot of times people will like to put it in what's called descending order. In other words, usually you would look at the exponents. So usually what you would do is you would check the exponents, and you want to put the highest ones first.
So do you want to put that
So
one first?
you would probably put this one first. You can go to the y's then and see, well, there's also a y to the third. Sometimes you might want to put the y to the first one first. But as long as you go descending in the x's, it's going to be much easier for doing most problems. So usually you would probably write the final answer like this. Now for one like this, I wouldn't take off if you had it in the other order, but I'm just going to make it pretty. Yeah. Yeah, that's okay. I can say things like that on the video. I'm going to make this one pretty. Alright, so you have these, and it's also a good thing for me to have done that because it shows that when you move them around, make sure that you keep the signs that go with each individual one. Like this was a negative 2, make sure you make that a minus. This was a minus 9, so make sure you keep it with its original piece. Okay, so very, very simple. Again, this is review from last year. Combine like terms when you add the polynomials. Not too much to do. Now this one is not a monomial, it's not a binomial, it's not a trinomial. It's just a regular, just a polynomial. Happens to have how many terms? 4 terms. And what's the constant term in this polynomial?
9.
Almost. Negative 9 is the constant term. What is the coefficient of the x squared y to the third term? What is the coefficient? 4. Coefficient. What is the coefficient for this term? Negative 2. And the coefficient for this term is positive 9. Okay, so I managed to get in a little bit of other review there. Okay, anybody still writing? Okay, let's move on. Subtracting polynomials. Subtracting polynomials takes one extra step in order to make sure that you don't make a mistake. Some of you will be able to mentally do this, but until you get really good at it, you're going to make sure that you're carefully changing the sign of each term as you go. So, didn't want to do that. So let's see if I can get a nice polynomial in here. It's going to make me... All right, it doesn't like me.
I don't like me either.
There we go.
I love it.
All right,
I
so
don't care. Okay.
let's do this one, 3x squared minus 7x plus 3. Now we're going to do minus. Okay, this is the only thing that's a little bit different. 7x squared plus 4x minus 5. All right, now this one will be a good example of why it's important to change the signs as we go. Get rid of this. All right. Before you start to combine like terms, usually it makes it a lot safer is if you rewrite the first one and anything that comes after the minus sign, change the signs of everything inside. So really this becomes our 3x squared we keep. Our minus 7x we keep. Our plus 3 we keep. Then we need to change the sign of everything inside this second polynomial. So 7x squared changes to negative 7x squared. 4x changes to negative 4x. And negative 5 turns into plus 5. Now sometimes people, if you are finding yourself able to do this in your head, that's great. But if you're finding yourself consistently as you do the practice problems getting them incorrect, this will clear up every problem you may have had. Always, 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 after the minus sign, you have to change the signs of everything in that polynomial. Charles, question? Never mind? Okay. So let's look for the like terms. Philip, what's a like term with 3x squared?
7x, negative 7x.
Negative 7x squared. So what do you get when you put that one together with that one?
Negative 4.
Good. Negative 4x squared, and I'm glad you didn't change the exponent because you don't do that. That's good. Negative 4x squared. Sabrina, what's the like term with negative 7x?
Negative 4.
Negative 4x. So we put negative 4x and negative 7x together, Julia, and you get
Negative 11x.
negative 11x. And then, Preston, what goes with the 3? 5? And gives you 8. So I've got all the like terms together. Here's my nice polynomial. It's put together in descending order. We have the x squared term first, and then the x, and then the constant. You are going to want to make it your habit to do this, always putting them in descending order. In all of your math classes, I'll say the math classes, because once you hit physics, then we reverse the whole thing. So,
Ooh!
Beautiful. Not quite sure why somebody in their wisdom teaches it in the math classes and then science you flip it, but it's okay. You need the solid foundation in math to understand the physics. All right, so subtracting polynomials. You change the sign of each term inside the parentheses. Really, really important to do that before you put the like terms together. All right, any questions on that? No? Okay. Now, next part, multiplying. Multiplying a polynomial by a monomial. Yes. Back question. Yes. Question.
Okay, so with the negative 4x squared and the negative 11x, the x squared is not the same as just the regular x. Like, you can't put those together and make x.
Correct. Because the exponents count how many times something is multiplied by itself. So really, if you were trying to combine an x and an x squared term, this isn't just 3 of the same things that you have 7 of here. Okay, this is 3 of x times x's. This is 7 of just one x. Okay, it's 2 completely different things. You can't combine them unless they have the same exponent. Okay, and when you do combine them by adding or subtracting, you don't change the exponents.
Oh my god.
Okay, that's why you have the 7 and the 4 go together to make the 11. You keep the x, just x to the first power. Multiplying is something different. Okay. Exponents count how many times multiplying. Coefficients count how many times added or subtracted. They count 2 different things. Okay. Hopefully when we do the multiplying, that will kind of work itself out and you'll begin to see why. Actually, when we get to the factoring, you'll start to be able to see why a little bit better. Multiplying, it does change. As a matter of fact, that's the next thing I want to do. Okay. Multiplying a polynomial by a monomial.
Whoa.
Okay, now we know that there are more simple and more difficult monomials. So we'll start with the simple one. Okay, so, oops,
Oh gosh.
for whatever reason. Oh, here we go. I'm going to start with the simpler one. That's interesting. Okay. So let's take something really simple. A simple monomial like
2 and 5.
2. Sure, we'll take a simple monomial like 2. A monomial, remember, can be just a single number. You put it the monomial right next to the parentheses, that means times, so 2 right times that. And I could then have something like 4x squared minus 7x plus 8. 82. There we go. That works.
That's not simple.
All right, so that actually is a fairly simple monomial times a polynomial.
Fairly.
Fairly simple. What that means is you're going to take this monomial and you're going to distribute it. You're going to multiply it times each one of these terms in the polynomial. Okay, so this really, when it's just a single number, it becomes pretty simple. So I take 2 times this first, and that gives you 2 times 4, which is 8x squared. Okay, so when you have a simple number, you're just multiplying, you're distributing it, making sure that each piece of the polynomial gets its part. So then you take 2 times negative 7x, and you get negative 14x. And then you take 2, multiply it times 82. Good. See, 164. You guys said it was hard, some of you, but it's not.
It definitely was.
That was a pretty easy one. All right, so that's all simple. You have a nice simple monomial times a polynomial. But you don't always have something that has no variables as your monomial. Sometimes you have to distribute something that's a little bit more difficult. So you have to combine your rules for multiplying with your rules for, for your rules for distributing. So let's get another one in here. Okay, get this. All right, so let's try and get in here. Let's do 3x squared y times negative 4x squared y squared minus 3x plus 4xy minus 7. Okay, now look, I made it age appropriately difficult. Age appropriately, yes, because you're no longer in junior high. You're no longer doing the super simple things. We're in algebra 2 now. All right, now once again, you need to distribute. So if we're going to distribute this, you're actually multiplying the numbers, but you're also multiplying x squared times x squared. So you're not multiplying the exponents. You're going to add the exponents. Let me write this out so you can look back at your notes later. If I'm taking 3x squared y, multiplying it times negative 4x squared y to the y squared. Okay, that's just the first thing. This really, you multiply the number parts, and that gives you negative 12. Now you're taking x squared times x squared. What do you do with those exponents? Add the exponents. Because you have 4 x's all multiplied together. Here you're taking 1y and multiplying it times 2 more y's, and that gives you 3 y's. Yeah. So the bases are the same. You're adding those exponents when you're distributing this monomial times a piece of the polynomial. So now we're going to multiply that part out. And so I'm going to write plus 3x squared y times negative 3x. Now, this step in here you probably won't write. This middle step, you'll probably just bring these things over and multiply them in your head, but you can't look back in your head when you're looking at your notes, so we're just doing this. So this part right here, the number part, Grace, is
the middle part?
The number part.
Oh, the number part is negative 6.
Not negative 6. Negative 9.
Whoops.
The coefficients, you multiply the coefficients.
X3.
X cubed.
Y.
Y.
Yeah.
Because you have 2 here and 1 more here, that makes 3, and a y. Now we need to multiply this one across.
Yay.
So plus 3x squared y. Shh. 3x squared y times 4xy. All right. Once again, 3 times 4 is 12, plus 12. X to the third.
X3.
Y to the second. There are 2 y's. The exponents are hiding. Okay, and then finally the last one, plus 3x squared y. Now, like I say, you're probably not writing this middle step when you're doing the actual problem.
We don't have to write that.
No, you don't have to write this part, but I'm just trying to show you what's happening for your notes. So 3 times negative 7 is negative 21, x squared y. Okay, and so your polynomial is now complete. You've distributed times each and every one. I didn't draw this in. Again, you don't have to draw these arrows in either. I'm just kind of showing you what's happening here. Okay? So monomial times a polynomial. You're just bringing in that monomial times everything that's inside the parentheses. Okay? And then multiplying the coefficients, adding the exponents for the like bases as you go. All right? And I know that in your Algebra 1 class you took many, many days to go over these type of things, but now we've got all of it. It's all review right in this section. All right? Now, next thing we need to do is review when you multiply a binomial times a binomial. This is going to be extremely important because we're going to end up having to eventually reverse the process. And we're going to have to basically unmultiply. Okay, we call it factoring. We're going to be taking, once we multiply the binomial times a binomial, if you can undo that, that's called factoring. So we need to get very good at multiplying a binomial by a binomial so that you can do that. So we're going to use the FOIL method. I don't know if you remember that. First, outer, inner, last. Now, you will see and hear FOIL method all over the place in math. But if you don't even remember FOIL, first, outer, inner, last, I'm going to show you it's really just distributing twice. Okay, so we're going to take a look at these two binomials. Okay, here's a binomial, here's a binomial. Okay, binomial because this one has two parts that are added, this part has two parts that are subtracted. Okay, you could have an add and an add or a subtract and a subtract. Now, the FOIL method means that you're going to take the first terms and multiply them together. Okay, so look at this. I've got the first terms. I'm going to multiply them together. X times x is x squared. There's the first terms. Actually, I might want to give myself a little bit more room here. Just because I'm showing you how to do it, normally I wouldn't need very much space at all. But so here's my x squared. The outer terms are out here. They're the ones on the outside. But look what I just did. Just like we did for a second ago, we distributed that first one. We just distributed it to both pieces here. So x times negative 5 is negative 5x. Then we take this number, this 2, happens to be on the inside right here with x, so there's my I for FOIL method, but you're really taking this 2 and beginning to distribute it to these other pieces. So 2 times x is plus 2x, and then the last terms, the ones that are left over or last, right there. 2 times negative 5, negative 10. Now this can be simplified, right?
Yes.
Can
The
I have
middle-
your attention, please? A retainer was found today. Please stop by the office to get it. Thank you.
I'm leaving that in the recording. Okay, here we go. X squared minus 5x plus 2x minus 10. We combine these middle terms. They're both like terms. And we get x squared minus 3x minus 10.
That's so hot.
And then this is the final answer. Sometimes you'll use the FOIL method, multiply binomials, and you'll get a trinomial for an answer.
There's another method too, right?
It's when you distribute this to both things, but really that's what we're doing anyway. This one got distributed to both pieces. This one got distributed to both pieces. And doing the distribution of everything in the first set of parentheses to everything in the second set will work no matter how many terms you have. Okay, I want to do another FOIL one for your benefit, and then I want to show you trinomial times a trinomial is not really that much more difficult. We can't use FOIL method, but we can actually distribute everything to one, everything to the other, and it's done.
Oh, okay.
All right, so this is still under FOIL, so let's do another one.
Oh, shoot.
Okay, so we want to do, first of all, this one times this one. That gives us 9x squared. Then we do this one times this one. Negative 18x. Then we do these inner ones and we get positive 18x, which is just fine. Then we do these last ones, negative 36. And when we go ahead and solve, what happens in here?
They cancel each other out.
They cancel out. So do I leave a 1x? What do I leave in here?
Nothing.
Nothing. Not a 0. I leave nothing in here. They're gone. So we just have 9x squared minus 36. Okay, that'll be my answer, yes. So sometimes you can do binomial by binomial and get a binomial. Sometimes you can do, like in the last example, a binomial times a binomial and get a trinomial.
Oh no.
Sometimes you can't actually get a monomial, but
That wasn't me.
but let's try this one.
I love my mom.
All right, let's take a look at this one. Let's multiply this out and see what happens. What's 2x times xy, the first terms? How many x squared? 2x squared y. Outers?
It will be 2x y squared.
2xy squared. I need everybody's attention. Inners
4x
plus 4xy.
and
The lasts
4y squared.
plus 4y squared. Now guess what? We can't combine anything.
So are we done?
So we're done. There are no like terms. So multiplying a binomial by a binomial, sometimes you get a trinomial, sometimes you'll get a binomial, and sometimes we'll get a polynomial with 4 terms.
Whoa. Speaking too fast.
So you have to be very careful when you multiply. First, outer, inner, last, and then carefully look for like terms. There are none here. There's a lot with the same variables, but the exponents don't match. Here we have an x squared, here we don't. Here we have a y, here we have a y squared. So it all has to match in order to combine them. So what we need to do now is I want to take a look at that one where we've got a trinomial times a trinomial. Just stick with me. Okay, stick with me because they're not as hard as you might think. I'm going to give myself some space above and some space below just because I want to show you what's happening, because normally I would just do this out and not really care about so much space, but let's just put this here.
Dude, chill.
Okay, now remember I said about the distributing thing? Really, all you need to do is distribute each term in the first polynomial times each term in the second. This will work for any polynomial times polynomial. So I'm going to start with this x squared right here, and I'm going to multiply it times each thing. I want to multiply it here, so that will give me 2x to the 4th. Okay, I'm going to leave myself a lot of space here. Going to multiply this one now times this middle one. Okay, x squared times negative 5x is negative 5x to the third. Then multiply this one times this last one. Okay, so x squared times 1 is 1x squared, or just plus x squared. Okay, there's my first set. My second set, I'll just pick another color here. I want to take this 3x and I want to multiply that times everything over here. So we'll start with minus 3x, negative 3x times 2x squared. That gives you negative 6x cubed. Then we will take this negative 3x and multiply it times negative 5x. That'll give us positive. Negative times negative, positive 15x squared. Because you have 1, 2x's multiplied together. Then negative 3x times 1. Negative 3x. Okay, I'm doing it in sections here. I'll just pick another color so you can see it. I mean, obviously you don't have to do the colored pencils to see math, but I'm doing this in a systematic way so I don't miss anything. Now I need to take this last one, this 2, and multiply it times everything. So 2 times 2x is plus 4x squared. Then 2 times negative 5 minus 10x. And then 2 times 1 gives you plus 2. Alright, now that is not as bad as it looks because you're just going to look for like terms. Okay, we're going to look for like terms. 2x to the fourth doesn't have any like terms, so it just gets to come down. But 5x to the third does. There's one. So we'll put them together. So negative 5 and negative 6 is negative 11. And now we do not change exponents because we're adding or subtracting. Then we look for the x squareds. Here's one, but there's also one here. There's also one here. There's 3 of those. So you have 1 and another 15, that makes 16. And then another 4, that makes 20. Plus 20x squared. Okay, so we've used up those, I have this negative 3x here. That goes with negative 10x. Negative 3x and negative 10x minus 13x. Then the only thing left is this plus 2. Now this is actually finished. There's the answer right there. Now, like I said, that sounds really complicated, but it really isn't. It's just doing one problem after the other with things that you already know how to do. Then looking for the like terms, putting them together. All of this math is just taking the things that you know how to do and putting them together. You are now in a position where you can complete assignment 41. My plan tomorrow is to try to get you to the point where you can complete 42 as well. Actually, what's on 42?